Yeah, I know. There's gaps in seats, so feel free to come in to the front. You get a better view of the slides. I don't bite, at least not in the first 15 minutes of the talk. Welcome, welcome. There's some seats in the front. Please feel free. If you're comfortable, that is, please come in and have a seat. All right, let's start. Thank you all for coming this evening. My name is Fendi, or my name is Leo Fendi, but I prefer to be called Fendi. And thank you for coming. I'm from ThoughtWorks. I'm a developer, and I've been in ThoughtWorks for about 9 years now, primarily as a developer. So it's always been a technical role, but I've taken on a developer role, a senior developer role, technical lead, technical principal, and most recently, I take on more of a coaching type of role. So within ThoughtWorks, I teach my colleagues for their technical leadership skills. In fact, that's a little bit of a segue or a preamble towards this topic. When I was in China, some of our colleagues are moving on from a senior developer to a technical lead, and they want to gather or they want to gain some software architecture skills. And I came up with a whole day, 8 hours worth of course, which is actually now compressed all the way to about 45 minutes for this talk. It covers a lot of what we cover in that course, that whole day course, but it won't be covering all the things. There's a lot of the exercises that we skip, and it's going to be formatted more of a talk and a presentation instead of a course. But yeah, it's going to be covering quite a broad overview of it. Just a very, very quick PSA. Firstly, there is going to be quite an amount of material that we're going to go through. So I opted just to put the questions at the end. So there are going to be a time that's dedicated for questions. So if you have anything that you want to ask, just write it down, and then you're going to have an opportunity to ask the questions later on. Next is slides. That's the picture in the middle. You're not going to get access to the slide, unfortunately, for this one, because I take heavy inspiration from a book, and I haven't gotten permission from the author to actually distribute it as slides for obvious reasons. Feel free to take pictures, but I wouldn't be able to share this slide, so unfortunately. Finally, feedback. You might have seen a couple of QR codes that you can just scan and a link. I'll also just put some QR code at the front for just an opportunity for you to give me feedback about how this talk went and whether or not you find it valuable. All right, let's jump in. Let's start with the agenda. Motivations for this talk. It's pretty much what you've read in the blurb. If you came here from Meetup or Eventbrite, it's the same agenda. We aim to uncover or at least be able to answer some of these questions by the end of this talk. What is an architect? The person that is. What is software architecture? We mention design, this word design, and we throw it all the time. How does design actually fits into the theme of architecture? And when you are, for example, thrown into this role, then maybe you want to ask the question of like, when is it the right time to make technical decisions, to perform this decision making? And you're going to work with different people, right? And quite common or quite in a typical situation, you would be working with a delivery team, and you probably would be part of an architects guild or an architects group. Then there comes a question on like, between this delivery team and an architect, who should make decisions, right? And we're going to discuss that as well. And if you are making decisions, what should you be focusing on? So it's a rough idea on the agenda, so it's going to follow roughly like that, but hopefully by the end of this talk, you'd be able to answer some of these questions. Not some, all of these questions, sorry. All right, let's start with the term architect, at least software architect. Now, I am borrowing the visualization and the definition that comes from the book. An architect is someone who sits in the intersection of these three different concerns: business concern, technology concern, and users. And that, I really like this visualization. I like this, the way to define it as an intersection between these three. Because typically when you talk about architect, you talk about the business and the technology. I said, okay, technology should serve business, but you might forget that at the end of the day, whatever this application is going to be used for, or the system, is going to involve the users. Irrespective whether it's an internal users or external users, there's going to be an aspect of that. And we're going to actually revisit this idea again with regards to an architect really needs to sit within the user's concern as well. When I think about architect, when I think about the word, I think about any description as more of a role. And if we think about role in terms of like problem domain, I think about role as a collection of responsibilities. And this is probably one way that we can consider what an architect is. It is a collection of responsibilities. There's 6 main responsibilities. There's probably more, but I would consider these to be key. And I'm just using metaphors for each of them. The first one as an investigator, a butcher, a tactician, a judge, an instructor, and an entrepreneur. Very, very distinct, different types of roles. But how does this all meld and would describe an architect? Let's start with an investigator. A problem well defined is a problem half solved. You might have heard of this before, but I think this is a good description of an architect. With regards to an architect being in an organization, in a company, working with other people, really you need to understand the problem domain first before you come up with a solution. Because typically what an architect would do would be coming up with technologies or patterns or solution that would actually solve the business problem, keeping in mind the users in mind again. Next is a butcher. And this is because irrespective of the level of complexity, whether or not it's a huge system or a small system, very likely an architect will be dealing with non-trivial problems. And that means there is going to be instances where an architect would be coming in and he or she would need to be able to partition the problem and also figure out which team is going to need to deal with which aspects of the problem. How do you eat an elephant? One bite at a time, right? You partition them and then you start solving smaller bits of the problem. Start small, think big. This is a quote by Steve Jobs. I like that. But when we talk about splitting problems into smaller subsection and actually allowing it and dividing it to different people, different teams, you also need to realize that as an architect, the responsibility really deals with the whole system. And that's really the longer term vision of what the system is going to look like. How does the architecture is going to solve that? And this is about the vision. This is about the big picture, not dealing with the minute details, but really the broad strokes and the vision. And this metaphor of a judge, there are no solutions. There's only trade-offs. It's probably a bit harsh, but I would think about it like there's no perfect solution to anything, right? Whenever you're presented with a different option, the one option is better than another only relative to one another, as well as only relative to the case that it's presented with. And in fact, across time as well, it's like the same decision might not hold true with regards to whether or not it's appropriate given a different situation. Talking about trade-off, there is no silver bullet. And this is a trap that sometimes people fall into because maybe you're a developer, maybe you've used Ruby on Rails before and that works well for you. And then the next time you go to a project and then that's the solution that you presented with. It's like, no, I've used Ruby on Rails before. That's great. Let's not use any other technology solution. But that applies to any other type of technology name. You can insert any technology name there. It could be Salesforce. It could be Oracle that you've used before and it works. But in the different situation, it could actually be different as well. There is no silver bullet. Everything is a trade-off. And here's just one example of it. The CAP theorem, consistency, availability, and partition tolerance. This is something that was mentioned a lot in distributed database system. Whenever you are making a choice on what type of persistence mechanism that you are going to use, you're going to make a decision on whether or not you want to satisfy a highly consistent system, a highly available system, or something that needs to live and perform under different network condition, which is the partition tolerance. The CAP theorem suggests that whatever solution that you choose, you probably can only choose 2 out of these attributes. That's just an example, right? Next is a mentor. A rising tide lifts all boats. People attribute this quote either to the Regional Chamber of Commerce in New England Council or JFK, John F. Kennedy. But what it's trying to say is try to actually get people to be capable, right? An architect really is not about making the decisions in isolation or just the person that has authority and control over everything. It's really about empowering different people. It's really about educating different people such that you can actually scale yourself as an architect, so you can make other people make good decisions instead of you being the single point of control that makes all the decisions. An architect needs to grow the architectural capabilities of others. Last but not least is the idea of an architect being an entrepreneur. He who is not courageous enough to take risks will accomplish nothing in life. And this is the idea of risks and technical debt. Notice the language there. Balance risk and manage technical debt. It's not about eliminating risk. It's not about getting rid of all the technical debts, because there are going to be situations where it's beneficial to have some technical debt. And it's perhaps not practical, nor is it going to be cheap, to pay off all your technical debt. Sometimes you actually need to live with it, but then the choice becomes on which technical debt do you want to live with. Here is a quick summary of just all that. An architect should define the problem, like interview, figure out what it is, partition the system like a butcher, keeping an eye on the bigger picture like a sports coach or a tactician, decide trade-offs like a judge, understand what the trade-offs are that exist, as well as make a decision, grow the team's architectural skills, and manage technical debt. Right, we've talked about an architect. So what about software architecture? What is it? I like to borrow a definition from Grady Booch. Grady Booch, for some of you who might not know, Grady Booch is the father of UML, Unified Modeling Language. Used to work in IBM, not in IBM anymore, I don't think. And he is considered one of the father of one of the father of software architecture, I guess, the idea and the practice of software architecture. He started out with this quote: "All architecture is design, but not all design is architecture." Let's stop there and just discuss what that means. There's many types of design, right? Product design, interaction design, visual design. And if you ask the question on whether or not interaction design is architecture, probably not. Just intuitively, you know that that's not architecture. It's design though. What is design? What is visual design and interaction design and all that? Design is really an intentional process to solve a problem, right? When you talk about not all design or architecture, it's just because just solving problem is not just the core bit of architecture. However, an architecture, whatever that means, is there to solve a problem, and it's there as an intentional process. However bad that architecture is, it's there to solve a problem. So all architecture is design, but not all design is architecture. Architecture represents the significant design decisions that shapes a system. So over time, you're going to make some more and more decisions. That's going to be represented by the architecture. But what is significant? Significant is measured by the cost of change, how difficult it is and how expensive it is actually to go back against something. And that's what software architecture is. Taken from a different angle, you could define architecture from Michael Keeling, the person who wrote the book Design It, came up with this definition. Software architecture is a set of significant design decisions, similar to previous one, about how the software is organized to promote desired quality attributes and other properties. Okay, design decisions, software organization, and what is it about? It's really about quality attributes. Quality attributes, also known as non-functional requirements, like performance, speed, maintainability, testability. All of that is going to be represented in your architecture. Okay, let's switch gear a little bit, especially because we kept on talking about this idea of design decisions. If we are going to make design decisions, this intentional process, we need to get to the thinking of design. So how does design fit into architecture? Let's introduce this idea of rules of design thinking. I put an icon of a heart there because it's probably easy to remember it as an acronym. H-A-R-T. Unfortunately, it's not H-E-A-R-T. It's H-A-R-T. It sounds like a heart, and therefore, it's probably easy to think of it like a heart. What is this H-A-R-T? There's 4 rules of design thinking. First is design for humans, H. Second is preserve ambiguity. Third is all design is redesign. And the fourth is make design tangible. All right, we're gonna go through each and every one of them. Let's start with design for humans. You might have heard of this before. Process should serve people, not people serve process. Especially for people who might be experiencing, who might have experience working in a very enterprise, very bureaucratic environment. Then you might see in some instances where you have a process like, I don't know, signing up for an email or getting your passes. And that process has been evolving for quite some time to the point that it's quite cumbersome, and people keep on following that process. And why do people keep on following that process? Because it's there, because that's what's there, right? And then what eventually happens is that you need to follow the process because that's what the process is, not actually understanding what the intent behind the process. So really, if you have a process, you need to understand what the intent is and making sure that that intent actually serves the purpose. And that's the same with architecture. So architecture, when we talk about design for humans, it's really about fulfilling the intent. This is just a picture of a concrete umbrella. It's beautifully designed, beautifully polished. It's probably going to be a lot of effort making this concrete umbrella. But then if you ask the question of whether or not it serves the need, then probably not, right? So this is an anti-pattern. So this is the Excel icon just because I want to stop with an anecdote. This is a project that I've been before in a client. The need is really about getting an Excel sheet which contains some information about some stock keeping information, parsing that Excel sheet and putting it into a database. That's the need. Some of you who have been in software before could probably say, okay, I probably know a technology that solves that. It's probably going to take, I don't know, 2 weeks, 4 months, whatever it is. But it's probably in the smaller side. Literally, it's just parsing and putting it into a database. The team that I went to created an asynchronous programming model put with an event-driven architecture. So you have essentially a queue in the middle using SNS, and you have the parsing mechanism on the left-hand side and another mechanism on the right-hand side to actually put it into a database. The project was late by 6 months. Obviously, the client wasn't happy about that, right? So the pattern here is really, if you need an umbrella, make an umbrella, right? It needs to fill people's need. So this is just a picture of a scrambled drawing. But sometimes when you are working with a big complicated system, your architecture diagram might look like something like this. It's just overly complicated. This is equally an anti-pattern, right? Designing for humans means somebody needs to understand what it is, right? Because people are actually going to implement this and it needs to connect. A lot of the complexity in software development and challenges in software development are not really in the technology side, it's really in the people side. That's just the fact. And what you might think is you don't start with a complex architecture. You start with something simple. And this could be something as innocent as a feature toggle. And again, I put this picture there because it's another anecdote that I would share. In one of the projects that I've been, you start with a feature toggle. That will be 1 or 2 features, but there's no discipline in maintaining the feature toggle. And soon enough, there's going to be a need from the product team or from the commercial team that says, you know what, I need somehow to have a sale event. A sale event that would turn on from January to February. That is a feature, not a feature toggle. Not a feature toggle that you would expect with regards to being able to continuously deploy, for example. And that adds complexity. And then instead, this feature toggle mechanism could then be used again for allowing some features to some specific users and not allowing some feature for another user. And then the bigger the application is, the more these type of needs comes in, the more complicated this simple, seemingly innocent feature toggle mechanism could be. And it just grows and grows to become more and more complicated. Really, again, the pattern here is to keep in mind on whenever you're about to add something, is it going to actually still be simple? Now, the opposite example, this is just me taking an example from Google Cloud Platform, gcp.solutions, and this is the domain of fraud detection. There are 7 components. 7 components for what you can argue as something that has a pretty complicated problem domain, fraud system. It's like, what type of volume are we talking about? How do you actually detect fraud? What if the fraud actually advanced and there's no more rules that could encapsulate the different types of fraud? Even the different types of fraud itself could be complicated. But GCP, Google Cloud Platform, came up and said, irrespective of the problem domain, it's probably likely going to be able to be solved with the 7 components. And the reason why there are 7 is just because of the assumption of the requirement of streaming, which means as transaction occur or as data comes in, you want to be able to detect fraud immediately. If there's no streaming, if it's just a batch solution end of day, it's probably going to look even more simpler. Again, irrespective of the complexity of the problem domain. And that's the pattern that you want to strive for. Design for humans really is about making it easy to be understood. This is the stereotypical view of an architect, the ivory tower architect. Someone at the top with a broad view, but not necessarily have good visibility of what's going on the ground. But at the same time, the developers, who are possibly separate teams, also have poor visibility on the intent and the ideas that this architect would have. And that's an anti-pattern, the ivory tower architect. Instead, look at the different personas or metaphors that we talked about previously. The coach, the mentor, and the tactician. What it implies is that an architect really needs to be working with other people. And design for humans means it's more than one person. It's a collaborative process. So the pattern here is architect is a collaborative process. All right. This is just a quick summary. If you are going to think about design, then you think about whether or not it fills people's need, it's easy to understand, and whether it's a collaborative process. You don't want to be blindsided as well. Okay, let's talk about preserving ambiguity. And this is the core tenet of Agile, like delay decisions to the last responsible moment. We're going to talk about why at the moment, very, very quickly. But sometimes people are a bit confused on what this idea or what does it mean to delay the decisions to the last responsible moment. Okay, let's come up with a scenario. Let's say you have 3 different options. Option A, option B, option C. That could be anything. Let's say you're about to purchase a CRM. It could be Salesforce. It could be Oracle. It could be an open source system. That is 2 different options. On the bottom gray line is a timeline, past to future, and now is somewhere in between. As you go along the timeline, at some point in time, option C, for example, will no longer be a viable option. Either the deal closes, or it expired, or there's nothing else that you can do. That would be what we consider the last responsible moment. Why? Because beyond past option C, a decision has already been made for you. Because that option is no longer viable, irrespective of whether or not you're intentional about it. But when a decision has already been made for you, then basically that's already the last responsible moment. Another way to think about this is, as an architect or when you are making a decision, there's going to be teams that might be dependent on the decision making or the decision made. They are going to be able to work up until a certain point. They're going to be able to work with an assumption, but at some point they can no longer move forward because a decision has to be made. And at that point, they're just going to be blocked. You're going to start costing the company or costing the team in terms of time and people, because of the delayed decision. That could also be considered the last responsible moment. Why? Why do we delay decision to the last responsible moment? This is reiterating what we believe in Agile. Software inherently is an immature thing. It's an immature process. It's an immature product, always going to be an immature product, whether it's languages, whether it's language frameworks, there's always going to be something new coming up, better, newer, shinier stuff. And by delaying the decision to the last responsible moment, you're allowing for these type of things to occur. With Agile, with the type of things that we're trying to do, both in software and in project management, really what we're trying to do is making the cost of change as cheap as possible and managing uncertainty, because change is inevitable, change is the only fact in life, and therefore we manage our software and manage our projects that takes into account that change is inevitable. Information, like during the time between now until you make a decision, you have that lead time, which means you have that lead time to do some analysis, and you're going to get more information. If you make a decision in January and you make a decision in December, between January and December, you can find out more stuff. And sometimes it's just pragmatic, because if you make a decision early, you're locked into a decision, makes it a bit difficult to change, but also sometimes you don't have to make that decision early, so you don't have to spend that effort or paying that cost, which is the last point, budget. Especially for large decision making, purchasing like a CRM or something, it's going to have a cost, both in maintenance, implementation, but that is opportunity cost, which if you don't have to spend it right now, you could have used that money, time, effort to do something else. The pattern here is to delay the decision. Now, ambiguity also apply in delegating decision making. So this is just an icon animation of like town planning. I don't know how many of you have played the game SimCity. So SimCity, this game, is really where you come in as a mayor or a town planner. You come in and what you do is you have a map of your city and you design the city by assigning zones. Residential zone, commercial zone, putting some roads, putting some power plants, and putting some water infrastructure around your town or your city. And that's how I imagine an architect role to be as well. It's an analogy, but the idea here is you're not concerned about the every single minute details of what's going on in your city. You're just coming up with some broad strokes. And this is just a couple of diagrams of organizational structure. And Amazon, Google, Facebook, Microsoft, Apple, and Oracle. But the point that I'm trying to make here is not about the organizational structure, it's about Conway's Law. For people who haven't heard of Conway's Law before, what the law stipulates is that the structure or the architecture of your system, your software, is going to reflect the structure of your organization. If you have 3 different teams and they're dealing with 3 different things, you're likely going to end up with 3 different systems, because that's just the communication structure, the department. And as an architect, what you want to think about, the pattern that I've seen over and over again, is this idea of a reverse Conway Law, which means you want to be actually involved in how the team is structured. Because if you want your architecture to be shaped or to look a certain way, then structure your team to act and to be actually managed in a certain way as well. The rules here is let the right decisions happen. And again, pay attention on the language. It's not about making the right decision. It's about creating an environment in such a way that the right decision actually happen. Delegating decisions. Next is all design is redesign. If I have seen further, it is only by standing on the shoulder of giants, Isaac Newton. What he meant here is that the reason why he is able to come up with a lot of discovery is because all of the previous work that has been done before him. Couple of questions. Should I fix legacy code? No, just rewrite everything. Anti-pattern, right? For obvious reasons. Well, hopefully not as obvious, because there is a pattern that is not as extreme as flipping the table. It is called the strangler application or the strangler pattern. What it means is that instead of pausing all the development and have a big bang release against a new refactored solution, instead you want to try piecemeal at small steps at a time to start migrating the application. In this case, you start with an original monolith on one side, and then eventually you create a proxy and start creating a service that migrates the functionality. And the original monolith is going to be migrated more and more, and it's going to be less and less important. The pattern here is really about incremental improvement. All design is redesign, respect the previous work, and have incremental improvements. I need one report. Let's have a reporting engine. Also an anti-pattern. This is a case-by-case basis, obviously. But this is, I guess, the other extreme. I need another report. Let's build one from scratch. Also an anti-pattern, right? And why is that an anti-pattern? It's really, as an architect, you need to find the balance between over-engineering and just creating clones of everything, which you need to manage. And it might be a little bit obvious, but it seems like the decisions is flipped. You say you need one new report and you create a new report engine, or one additional report and build one from scratch. It probably makes more sense if you need to create a new one, and that's when you build one from scratch. If you need to create another one, that is the right time to introduce something that is more generic and reusable. So the pattern here is reuse correctly and timely. This is just a quick reference, irrespective, for people who are working in the cloud, that is, irrespective whether you're in the GCP, AWS, or Azure cloud, then there's actually quite a lot of library of references, white papers, and case studies on how things are implemented in such a way that it will be scalable and fulfills a lot of the quality attributes that you'd be looking for. I would suggest and highly recommend that you look at that before inventing something yourself, right? Finally, make design tangible. We favor the visible, the embedded, the personal, the narrated, and the tangible. We scorn the abstract, by Nassim Nicholas Taleb. This is one of my favorite author. He came up with the book Fooled by Randomness and the Black Swan. But it's really talking about this idea of abstract being quite dangerous. But hold on, you mentioned previously that we should preserve ambiguity. But now you're saying we don't like abstract. What does that mean? Well, let's try to define the word a little bit more. Abstract here means theoretical, means unproven, untested. Ambiguous, when we mention preserve ambiguity, is about not being locked in. So that's slightly different. When we talk about making design tangible, it's really about testing it out, spiking, prototyping, documenting, analyzing, right? It's not about making a decision. It's making sure that you have the information to be able to make a decision. And this could come in different forms. This is the C4 model. It's Simon Brown came up with the C4 model with regards to architecture diagrams. You can draw it in the context system software, the container level, the component level, or the code level, different levels of abstraction. This is a sequence diagram. Some of you who are probably a bit more technical might have seen this before, but this is a good description or a way to describe how the system behaves or how different systems interact with regards to the flow of time. And this is domain-driven design. This is a context map, another tool that you can use. One of my favorite tools is the architecture decision record. So instead of creating a 100-page solution architecture document, what you can instead is coming up with a more lightweight solution to documenting your architecture, which is essentially a decision log. So at January, we make this decision. In February, we make a different decision. In March, we make yet a different decision. And here are the contexts around it. Because that now takes into account that things are changing. All right, let's switch gears a little bit and talk about design mindset. We talk about like how should you think about it. Design mindsets are really the activity, the separate activity. And I apologize. I'm a little bit of a technical person and it's not my presentation if I don't put this icon up there. This icon is the Vim icon. Vim is a text editor. I put it up there because Vim is a modal text editor, which means at any given point you need to be in insert mode or normal mode. And that's pretty much the extent of it. For this audience, really, this is probably a better explanation. Modes of transportation. If you want to move from point A to point B, really you can either walk or take a bike or take a taxi or take a bus. You wouldn't be riding a bicycle and taking a bus at the same time, unless you're a stunt person, right? But the idea here is each of those modes of operation have its advantages, disadvantages, pros and cons. It has its different purpose and its different place. And that's the same with design mindset, the different activities. You're going to be in 4 different modes. There's no priority to these modes, and there's no sequence of time as well, which one you have to do first. It's just 4 of them. There's the understand mindset, the explore mindset, the make mindset, and the evaluate mindset. It is probably easier to grasp if we start from the understand mindset. You start from the understand mindset. What is it that you want to understand? You want to understand the business goals and the quality attributes that's necessary for your system. And then the next phase is probably the explore. Because what are you going to explore? You're going to explore patterns, technology, and solutions. Why? Because they need to promote the business goals and quality attributes. Keep in mind that at this point in time, everything is still abstract. It's just ideas. You just explore things. These are different things that could possibly solve the problem. How do you make it concrete? You make. And what do you make? You make prototypes and models. This is, again, the idea about everything that you need to actually make the design tangible. The prototypes and models would realize the patterns, the technologies, and solution, and they really need to demonstrate the business goals and quality attributes. That's not the end, though. You're going to end up with a system, and you need to be able to evaluate those systems. You evaluate the prototypes and models in order to see whether or not it fits the business goals and quality attributes. And here is the full picture. Now, I mentioned that these are the different mindset, the different mode of activities that you can do. I'm going to give you very quickly of the example activities for each one of them. For understand, some of you might have done a trade-off slider. A trade-off slider is really a prioritization exercise. That's about understanding. And there's other activities right up there in the slide, which I'm just going to skim very, very quickly. Requirements gathering is part of this. The keyword is empathy. The keyword is making sure that you're on the same page. And I guess the persona is really that investigator or detective. Next is the explore. And explore is really about big picture, about vision. That's the keyword. And one of the activity here is event storming, or some sort of a whiteboard jam or design sessions that you do with your team. When you're coming up with a whiteboard and start drawing boxes and lines just to come up with some solution, that's where you do the explore mindset. You can see that this is a distinct activity compared to like the understand mindset, because by that time, hopefully you'd be already at the position that you are at least having some information on what you need to solve. Next is the make, and this is concept to artifacts. Once you draw something on the board, that's probably ephemeral. It's something that's going to be wiped out. You probably have to document it somewhere. So you want to go into the make mindset. This is really about drawing and documenting stuff, but also just a further step from the analysis. An architecture decision record will fall under here. Some decks, some spikes would fall under here as well. And finally, the evaluate. The keyword here is analysis, and this is where you put on the hat of a judge of understanding all the trade-offs and whether the things fit together. One of the activity here would be actually looking at the code review to see. All right. We talk a lot about design. And part of the definition is we talk about design decisions. So let's talk a little bit about decision making. Who makes decisions? On the left-hand side is just an icon that represents an architect. On the right-hand side is an icon that represents developer. There's a line there. Intuitively, you might think about, okay, an architect might not be making all the decisions, but at the same time, it might not be making no decisions at all. There's some decisions that needs to be made one way or another, right? There's that seam there. So what is that seam? Where is that line? And to do that, I want to introduce the concept of RACI. R-A-C-I. R stands for responsible. Who is actually delivering? Who's performing the task? A is accountable. Who makes decisions? And liable. Who needs to answer to some questions if things go pear-shaped? Or essentially, whose head is in the chopping block? who gets fired. C is consulted, who has the information to help. And I is informed, who needs to be updated on progress. Let's go back to this diagram. I believe that an architect is sitting on the A and C, on the accountable and consulted. They are liable. They are going to be needing to answer questions if things go pear-shaped. That's precisely why they're there. They also sit in the C, which is consulted, because most of the time an architecture will be cross-team, sitting in a higher level, which means they have more information that would help in decision-making. However, the developers or the delivery team are the one who sits in the R, or the responsible. So they're probably going to have the most information with regards to the software. Okay, maybe a better question is to understand what decisions needs to be made. And we go back to the definition. A software architecture is design decisions to promote desired quality attributes. Okay, if it's decision that promotes quality attributes, that means an architect should be considering quality attributes. That line there is really to understand, okay, am I making a decision about performance? Am I making a decision about maintainability? Am I making a decision about how cheap it is and how the team is structured to be able to handle the software? If so, that's probably something that lives in the domain of an architect. We also mentioned significant, and that's probably relating to inertia. So then the question there is like, is this decision going to be really expensive? And therefore, that probably should, again, live in the domain of the architect because they're consulted and they have a broader set of information. And risk. The larger the risks are, the more likely that an architect should be involved. But how? All right, so you make a decision. Are you just going to, I don't know, fire people if they don't follow your design decisions? Not necessarily, right? There probably is a better way to make sure that the decision is maintained. And I would like to introduce at least two tools that can be used. One is an architectural guardrail. For people who might read the Evolutionary Architecture book by Neil Ford, Rebecca Parson, and Pat Kwa, they talk about the idea of fitness function, which is essentially a test against your software architecture. So a fitness function would be like an automatic test. People might have heard about Netflix and the idea of a chaos monkey. So there's a software running in Netflix that at certain period of time in production just shuts down the service and see whether or not the reliability and the availability is maintained. That is a fitness function because that is an automated process that checks for the quality attribute of your architecture. An architectural guardrail I would consider like a manual fitness function. This is an architect coming up with whichever system that you choose, whichever system that you come up with, it needs to respond within 5 milliseconds. And you gave that information to your delivery people. So then they have a clear idea of what quality attributes are important, and then they have the decision-making ability to satisfy those types of requirements. So it's really about communicating the quality attributes or the quality attributes requirement. The next tool is sensible default. And I think about this like an FAQ, frequently asked questions. It's probably a little bit different from a frequently asked questions, but share some characteristics. A sensible default would be, if you are about to start a project, if you are about to make a decision, especially it relates to what language should I use? Am I supposed to use, which build mechanism should I use? Continuous integration tool should I use? How should I deploy things to production? There is probably a standard inside your company, right? And it probably is going to cost a lot more to deviate from that standard so that it is beneficial to get people to conform. And that will be a sensible default, right? You would distribute it to your delivery team and say, in our company, we prefer to use Java. We prefer to use BuildKite. We prefer to deploy using Kubernetes. You may depart from these, but we should probably have a conversation beforehand, right? Because it needs to be a very strong case on why you need to depart from some of the standards. And what would inform this architecture guardrails and sensible default? It's the quality attributes, the amount of risks involved, and the inertia of the decision making. Time investment, right? We talk about decision making, who makes decision, who makes what decisions, how you're supposed to implement those decisions. how much time are you supposed to spend on some of this decision making? Here's just a very, very simple formula with a lot of assumption. The assumption here is it's a linear progression and it's not a parallel work, which means you start doing some architecting work, there's going to be some development work, and eventually some bug fixing work, which is a linear, and therefore it's just a sum of it. If you sum the architecture time, the development time, and the bug fixing time, you're going to end up with the total project time. It's not really true, right? But let's start with that assumption, because this is, we're going to make a different point. I intentionally don't put any axis there because it's going to be a lot more complicated. It's conceptual, but it is actually derived from observations. There's data backing this up. So again, making the assumption that it's a linear process and sequential process. The more time that you spend in architecting, the more likely that less bugs is going to arise, because people are actually able to build it right the first time. Whereas if you don't spend time finding out the information, there might be some change or some rework that needs to be done later on. What they found that is the architecting time is going to be linear, but the bug fixing time is not linear. And therefore, there's going to be a sweet spot somewhere in the middle, not too much or not too little. There's going to be a sweet spot there. Now, the point that I'm going to make is that sweet spot changes depending on the size of your project. The bigger the project is, the more code that you have to rewrite, right? This is 10 million lines of code, 10,000K line of code, 10,000 line of code. Therefore, if you don't spend time architecting, which is a linear time commitment, if you don't spend time architecting, then you're eventually going to rewrite a lot of stuff. Therefore, it's worth spending the time to do the architecting. It's worth spending this much time to do architecting because you're able to reduce the rework. If your project is small, like 10,000 line of code, probably it's not worth doing like extensive 6 months analysis on a 10,000 line of code type of project, because you can just pretty much rewrite the whole thing and it doesn't cost as much. The reality is always going to sit somewhere in the middle. For people who are probably a bit more familiar with Agile and change, and you might feel a bit uneasy about this big design upfront kind of thing, right? And that's what I want to highlight. Please consider that the cost of change is always going to be there, irrespective of whether or not you do the architecting upfront or the decision-making upfront. There's going to be some cost in doing the analysis, because if you analyze the wrong thing, then you're going to need to spend time analyzing some other thing. And if you've analyzed it, you've already done some work, and you need to throw it away, then that is also sunk cost. In which case, or what would throw a wrench on the works? Where is the source of change, right? It could come from at least these 3 different things. Incomplete information. I believe that there's absolutely no way that you can come to a state where you have complete information. Incomplete information is just like, oh, we didn't know that that was the case. So even if you have some information, it might not be true. So it would be incorrect assumption. We thought that was the case, but apparently no. So new information comes in. Or it might be true at a certain point in time, right? It might be true in January, but it no longer be true. It's no longer true in March. So changing environments just means that your old information is now obsolete. So keep that in mind. And that's where I draw the line with the effort that you actually spend with regards to architecting. There's a line between big analysis upfront and big design upfront, I would say. And with the big design upfront, it's really about the decision making. Remember we mentioned about delaying decision to the last responsible moment. The more decisions that you make upfront, the more danger you're going to be in. Here's pretty much a decision tree that I make. It's a very, very oversimplified guide. So knowing that dealing with large systems require you to do a lot of architecting, your first question really should be, can you start small? Can you start with the simplest thing? And if yes, that's how you should do it. Start small. Start with just what you need. If you can't, then the question is like, okay, you can't start small. It's a big complicated thing. Can you split it in such a way that you're going to end up with a smaller part? If you can, then that's what you're supposed to do. If you can't, let's say, again, you're just dealing with a monolith and it's just so difficult, you're dealing with a legacy system, then your next question is, can you spend more time to do some analysis? If you can't spend more time with analysis, then have a plan B, or budget the rework time into your project management, saying like, you know what, we don't have time to do analysis. Let's just pay it later. That's, I don't know, spend 2 months after the go live or the release to make sure that we can fix the bugs. If you can spend time to do some analysis, the next question is, can you delay the decision making? If you can, do some analysis and find more information. If you can't delay the decision making, then please make a decision, right? And don't block other teams, and have a plan B anyway. Make sure that you always have a contingency. All right, that's pretty much the end of my talk. So let's sum up. Did you get what you came here for? Is it worth your 45 minutes? I think we covered what an architect is and what software architecture is, how design fits into the architecture, when is the right time, and who makes what technical decision, and what is the primary focus for decision making. Again, it's just the quality attributes, risks, and inertia of decision making. What is an architect? It's someone who sits in the intersection of these three different concerns: business, technology, and users. I see it as a collection of responsibility: investigator to understand the problem, as a butcher to split the parts into smaller problems, tactician to keep in mind the bigger picture, judge to understand and make decisions on trade-offs, instructor or a mentor to make sure that other people also is able to make a decision, as an entrepreneur to manage risks and technical debt. What is software architecture? It's really these three things: significant design decisions, where significant is cost of change, and design means it's intentional. It's about how the software is organized. So software architecture is software organizations. Remember the reverse Conway law. And what is it about? It's really about quality attributes. If you are going to do design, then keep in mind the design thinking. Design for humans is really about the actionable checklist. Fill people's needs, make sure that it's easily understood, that it's collaborative process. Preserving ambiguity is about delegation and making sure that you can delay the decision to the last responsible moment. All design or redesign is about making sure that you respect the previous work that has been done. You don't throw away. It's about incremental improvements. And it's about trying to find the balance between over-engineering and just cloning everything. Making design tangible is really about proving things, testing things, documenting things, instead of leaving yourself in a state of high risk. When is the right time to make a decision? The last responsible moment. When is that last responsible moment? There's two ways to look at it. Either when one option closes itself, or when there is going to be costs starting from delays. Keep in mind the different activities that you can do. Understand, explore, evaluate, and make, which is the different modes of operation. And who makes what decision? Because the architect will be in the accountable and consulted area, then really it's about quality attributes, risk, and inertia. And everything else should be delegated to the delivery team. How much time should you invest? It really depends on how big the project is. But really, if you can have a choice, really try to make the things as small and as simple as possible. The source material, I took heavy inspiration from this book, Design It. A lot of the anecdotes are my own, but that's also the reason why I can't share the slides. There's some overlaps between what's inside Design It and what's in this slide. And with that, I open up for questions. Any questions?
Do you really need an architect, or does architecture just happen on a project anyway?
My view has changed recently. When I was in the delivery team, and my role is just as a developer. I wouldn't say just a developer. And the type of projects that I deal with is slightly smaller project, again, 10,000, 100,000 line of code. I view architect as unnecessary, and that's usually because the decision-making would lie between the technical lead or the team lead or a project lead. once I start experiencing or being in a place where it's more complicated and more technical, not more technical, more complicated, bigger, larger monolithic legacy systems, I start to see the value of having an architect. So then really the answer is, what type of project are you dealing with, right? And that's similar to like the time investment earlier on. If like it's a small type of project, then probably it's not necessary. Do you mind passing the microphone, please?
You talked about delaying decisions until the last possible moment when it comes to architecture, but doesn't that also, like, and I can see the merit of that in wanting to make the most qualified decisions, but do you not also run into situations where you feel like you're making a lot of decisions under a very late kind of time pressured standpoint, where that could cost you maybe cost you from making the best decision possible?
I guess that's going to be a balance, right? It's really about whether or not it makes sense to delay, how complicated the project is, how much decisions that you actually make. And that I don't know, it's almost a cop-out answer, and it's like the definition of that last responsible moment is going to differ, I would say. Yeah. Does that answer your question?
Yeah, that's good.
Okay. Yeah. Sorry, do you mind passing the microphone all the way over?
Hi, so I just wanted to ask, as an architect, when you get the project or you start with your team, do you, because you're having multiple options and, for example, we have some kind of architectural pattern or something that you're trying to experiment whether this is better than that, do the developers, I mean, than a theoretical decision, you would rather have a proof of concept code or something. So would you recommend that each members are actually taking each option, like one guy does event polling mechanism, one guy does some other kind of mechanism? Is that what you mean by delaying and then seeing which will perform better?
It's definitely one element of it. So what that means is you're actually allowing to spike. If you can afford it, then definitely try to do that, which means you try to see the merits of each different solutions in practice, right? If you're spiking the solutions, it's definitely one of that. The delaying is really the concept of, you will never have perfect information, obviously, but the more that you can prevent yourself from locking yourself in, the more likely that you're going to be able to adapt if things actually occur. So that's kind of the idea.
Hello. The correlation that you pointed out in between number of lines of code and the requirement of an architect making architect decisions. So suppose if I have initially went with a 10,000 line of code and I have not followed any architecture initially, and as an architect I have not foreseen, as a project manager I have not foreseen future requirements, and suppose 10,000 line of code jump down to 100,000 or maybe 20,000, 30,000 line of codes. Won't it be difficult to rewrite or jump onto architecting that code, or would it be better to initially jump, like for 10,000 line of code also we do that?
That is a really good question, right? It's talking about the evolution of your system as it grows. What we're trying to postulate, I guess, suggest, is that if you start with 10,000, then it's probably not worth to start with. As it grows, that would be the right time to do it. We're not saying that you don't do it at all as the software grows, but when you see the software growing, then that would be the right time to do it for the decision making as well.
More painful in that, like rewriting 20,000 or maybe bigger code and architecting.
It's a really good point. One thing that we haven't mentioned here is the bigger the code is. For example, what I'm assuming here, and probably I haven't made it as clear, was that let's say you have a need. That need is really going to be satisfied with 10,000 line of code. This is going back to the Excel solution just now, right? And instead of saying, let's just creating an Excel parser, let's put an asynchronous programming model with an event-driven architecture and Kafka or SNS in the middle, let's say you come up with a really, really complicated system that is able to solve a lot of the different problems. There is going to be cost in maintaining that solution, right? And what you're trying to do there is when you make a decision at that point in time, you are now speculating, you're now guessing on the future requirements. There is a balance between which future requirements are like very likely and therefore it makes sense to put into the design, or whether or not it's just a guess. And I always really like to give the example of a startup, for example. A startup would say, oh, I have a startup of a banking application, and really it's about checking your bank balance, and you might have 3 different bank accounts. This application would allow you to check the total balance out of a 3 bank account. And that's the only requirement. And that could be solved by having 3 different import mechanism from the 3 different banks instead of a very, very complicated, again, event-driven architecture system or microservices that has many, many services. Maybe you'd start speculating the need of, oh, maybe I want to transfer between the 3 different bank accounts eventually, but not now. Now, if you try to incorporate all the solutions into this banking application at the beginning, there's going to be cost in developing it. So the users are going to probably receive it slower because you need to wait for this to be developed. But also, once the feature is actually in play, you need to maintain it, right? Irrespective of whether or not the user is going to use it. But if you are a startup, you might want to think on whether or not you have enough money to actually maintain it, or either the development or the cost of maintaining it. And in fact, as ThoughtWorks, we actually deal with a lot of the startups that eventually has moved on to a larger type of organization. And they have this technical debt. They have this issues with regards to not ideal design, for example. And we're trying to solve that type of problem. From my point of view, that is the right time to solve it, not at the beginning. Because you, as a startup, it's really a proof of concept. You're not even sure whether or not you're going to have users or whether or not you're going to survive the next month. And that mentality could probably apply to some other people. It's really about getting the biggest bang for your buck. It's probably enough time. Does that answer your question?
Yeah.
There's probably enough time for one more question.
A lot of IT organizations or in general enterprises 2 years, 3 years back had all these monolithic architecture in place, and now everybody's trying to move to a microservice-based distributed architecture. Now, when an organization who's currently on a monolithic architecture trying to transform their entire IT landscape, is it worth going big bang, having a separate microservice-based architecture developed and then switch over to that? Or is it always preferable to go step by step and build on what you already have and then move in phases? The reason I ask that question is, if you go in phases, there'll be a lot of technical depth that you would be putting on the system, because if you, let's say, have one application which is now moved over to a microservice or a few microservices, and they talk to the remaining of your legacy IT architecture, and then eventually they have to talk to other microservices at a later point in time, wouldn't that be a lot of technical depth onto the system?
There might be. There's always a cost towards any type of strategy, any type of tactic that you would go on, either using the strangler pattern that we described before or just doing a big bang release. Like I said, there's no perfect solution, right? It could go either way, and it really depends on like the size of the project. The reasoning behind it is to make sure that as long as you understand what is the intent behind having a strangler pattern, and then you can actually think about on whether or not it applies in your situation. With the strangler pattern, what we're trying to de-risk is there's going to be a period of time, for example, where the system is not in use, and that could be 3 months, 6 months, 1 year. The longer that time is when the system is not actually in use, the bigger the risk is. And when you say having a big bang release, it really, again, is dependent on how long that time is where you don't actually have users using your system, because that's the best feedback that you could get, whether or not there's going to be fulfilling any quality attributes that you have. Getting that feedback of actual users using it, putting it into production, and solving all that little problems, hopefully would de-risk some of the big bang. All right, that's the final question. I really thank you for your time. My name is, again, Leo Fendi. Please call me Fendi. That's my email. That's my Twitter handle. And this is the feedback form. Feel free to stick around. There's still a couple of pizzas and sushis. There's also a couple of QR codes to give feedback. Please give feedback so I can actually improve myself. And I really, really thank you for your time. Thank you. Hey. Yes. I worked with you for a bit, I think. Yeah.
So yeah, I'm in Melbourne right now.